today discuss something very special thing, which is called summability idea. Okay, so summability idea means that we are generally, what we are doing is like we are getting some sum of some, like say, terms or some elements of a space, and we are getting a new element from that space. So what is that? So in general sense, let us talk about R. So in R, basically summability means that like this 1 plus 2 equals to 3. But this is, this is finite case. So for finite case, it is very obvious that you can get a sum always. But let us talk about some infinite series like this, that half plus 1 by 3 plus 1 by 4 plus 1 by 5 and so on. And you can definitely see that this is like this series is basically divergent. We can basically see that because this is 1 by p series, so which is basically divergent. So in R, generally you can see this kind of thing, this kind of like certain sequences whose corresponding series is maybe convergent, maybe divergent. That is basically called the idea of summability. But if we talk about some, in general, some nonlinear spaces, so what is the definition of summability there? Means, of course, summability means we are basically getting a sum of infinite numbers or infinite elements of that space. So what is the idea behind that thing, like in an arbitrary nonlinear space? Okay, so what is the definition of that summability? Let us just define. So just imagine there is a space X. So with some, let's say, norm like this. So we are generally talking about nonlinear spaces, which is very like easier to handle or to work with. And if I say that let's say in this space there is a sequence xn of elements. So x can be anything, like x can be like a space of continuous functions, like space of polynomial functions, anything. So let's say xn. So if we say that xn, the corresponding sum means we are basically doing this kind of thing, like n equals to 1 to infinity, the corresponding that kind of thing, but not exactly that thing. So if I say like that xn is a nonlinear space, is said to be summable. Okay, is said to be summable. Summable to an element x in x. Okay, so s belongs to s. So xn basically goes to s, summable to s. So when we see that, or when we can say that, is this, when this kind of thing gonna happen. So sn minus s basically tends to 0 as n tends to infinity. Okay, so sn minus s, this norm, so inside this norm, with this norm, it gonna goes to 0. So what is sn? So you can just definitely see sn is basically xn, n equals to 1 to infinity. Oops, xi, and here I generally 1 to n, means the partial sums. Okay, means basically the partial sums. Got it? So that's how the basic concept is. So if this goes to 0, then it is said to be summable. Means you can say in other word that like that xk, k equals to 1 to infinity, it basically goes to s. Got it? And of course in that case it is not going to s, it is exactly s. This is the concept of summability. Understand? So this is called summability, and there is another term which is called absolutely summable. What is that thing? So that thing means this. So here is like say xk, this we take this norm, so k equals to 1 to infinity. If this goes to s, okay, if this goes to s, this thing, like it doesn't goes to s, but we just can say that this is less than infinity. Then we can say that this xn is basically like say absolutely summable. Okay, means if you take this kind of norm, so when you are taking this norm, this generally becomes some real numbers. Okay, because this norm is basically a mapping from x to real number, x to r. So then we say that this xn is basically absolutely summable, of course to some numbers. Okay, so that is basically the concept of summability and absolutely summability. Okay, so thanks for watching.